Yeah. Okay then. So telescopes on the moon. So I've got this slide here. Can you see that, the graph?
Mm.
Yeah. Okay. So viewing from the Earth, various frequencies are blocked by the atmosphere, gamma rays, and infrared absorbed by atmospheric gases. Radio waves are observable from the Earth, and long wavelength radio waves are blocked. One of the first telescope was on the moon was with Apollo 16, which was an ultraviolet telescope, which took 178 images of the cosmos. This is a picture of the telescope on the moon with the Apollo 16 crew member. And then they did these 178 images from the moon, but 41 years later, China put the Chang'e 3 lander on the far side of the moon, which had a telescope on it. And that was in 2013. It was called the lunar-based ultraviolet telescope, and it was a 50mm telescope observing galaxies and variable stars, binaries. And although it's only a small telescope, because there's virtually no atmosphere on the moon and the slow rotation of the moon, there's you can get an extremely long and uninterrupted observation of a target. So you can get long exposures. Some proposals that have been put forward. A bloke called Jack Burns at University of Colorado has done a study for NASA for putting a radio telescope with a spread of 128 antennas across a 6 mile area, 6 mile wide area. And it's called the Far Side Array for Radio Science Investigations of the Dark Ages and Exoplanets, also Far Side. This has been going for a while, and I think it's quite a promising proposal with NASA for putting this array on the moon. We would be studying magnetic fields around distant stars, understanding exoplanets, and also looking at the cosmological history. Now, a long time ago, around about the Apollo era, there was proposals then for putting radio telescopes on the moon, like the Arecibo type telescope. If you look at this picture, in the middle of it, you can see there's a moon base in between these three craters. And so it's quite a big area, and at the time they were proposing that astronauts would be going to the moon to build all this assembly. And at the moment, they've got a proposal for the Lunar Crater Radio Telescope, this LCRT, which has got a 1 kilometer diameter in a 3 kilometer crater. It would be able to have a look at 10 to 50 meter wavelengths. That's the 6 to 30 megahertz frequency, which hasn't been explored by humans up to now, because you've got a very long wavelength coming in, and if it's on the far side of the moon in a crater, it will be hidden from any noise coming from the Earth and the sun. So the low noise obviously would it aids them getting a lot better information that way. Just as a comparison, the Lovell telescope at Jodrell Bank is 3,200 tons, and it's got a diameter of 76.2 meters. So it's less than a tenth of the one that they were proposing on the moon, which is going to be 1 kilometer. And to achieve this this radio telescope in a crater, they would send up robotic landers. No need for astronauts to go up there. The lander splits into two. It lands the telescope in the middle of the crater, and a rover lands on the rim of the crater. And then the rover goes around sending out parts which would go down into the crater and grab hold of the cables on the mesh, which would then be dragged up the crater walls to stretch this radio telescope out to its full size of a kilometer. Now, the launch of the James Webb Telescope is, when it actually gets there eventually, is looking at the near infrared at very high redshifts, but it can't quite get far enough to look at the very, very high redshifts from a time when there were no galaxies, only stars in the universe. And a team of astronomers at the University of Texas, they've just published this paper with a concept for a liquid mirror telescope on the moon that was originally floated a decade ago, but it would be a liquid telescope. It would be a spinning vat of liquid topped by a metallic liquid like mercury or something else reflective, and it would run on solar power. So it would be positioned in a crater on the north or south pole of the moon, and this bath of liquid would then be rotated using power from the sun, which would then curve the mirror. It's going to be called the ultimately large telescope. But it's a bit of fun when other telescopes have been called the very large telescope and the very large array. This is going to be the ultimately large telescope, although I dare say you could top that with the vastly superior telescope, or mine's bigger than yours telescope, or something like that. It's looking at, it would be able to detect population 3 stars, and these are as faint as 39 magnitude, and it would need a mirror size of about 100 meters. Now if you look at the that photograph, that picture there of the that was in the illustration in the article, if that's a rotating bath of liquid on the moon, that's a bit misleading, is that? Because that's there's, if you see relative to the man who stood there, that's not 100 meters, that's more like 10 meters, I think. But these population 3 stars, they're divided into population 3, population 2, and population 1, where population 3s are the most ancient, which were formed just after the Big Bang, and there's very little metal in them. Physics, anything heavier than hydrogen and helium is considered a metal. So the population stars would have been much more massive than today's stars, and would be burning a lot hotter and bluer. But obviously, with the redshift, there would be a lot lower. There would be red in the telescope's view, because blue. Population 2 stars formed soon after that, and they have a higher metal content, and population is like what we have in our in our own star, the population 2 stars. Population 1 stars is what our own sun is. So the telescope would be stationary at the crater at the moon at the north or south pole to study the stars, and it would look at the same patch of sky continuously, and to collect as much light from that area of sky as possible with its ultra large mirror. So that's the end of it. Thank you.
Thank you, John. That was excellent. Anyone like to ask any questions to John about that?
A bit puzzled by the rotating liquid, which had a metallic surface. I mean, ideally, you'd fill it full of mercury, which would be a bit tricky to get up there. So, what have they in mind for a rotating liquid, which is very good? It does produce a perfect parabola, but it's got to have something on it on the surface to reflect light.
Yeah, I think they're looking at a liquid with a metallic liquid on top of it, but they seem to think that will be a lot lighter to get up there than.
What liquid will they starting with? It's no good putting water there; it just evaporate.
Even on the moon, you think it would evaporate?
Well, it's cold on the poles, obviously, which helps, but I don't know. Maybe it would work.
Yeah. These articles didn't go into that detail. I think they haven't got that far with it. It's a concept of the ones, the telescopes where they're looking at radio telescopes built into craters on the far side. They're getting a bit more closer to actually being implemented, but this is just a proposal on a paper, really, at the moment.
Wouldn't it be better to get humans back there to the moon to erect this stuff rather than relying on robotic rovers to pull these things, up to the position where they should be across craters? Because I think that these things can run out of power, they can go wrong or whatever, and then you're scuppered then, aren't you, really? I mean, I gather that one thing that NASA are definitely aiming to do is to build bases on the moon for humans to go back to, which can then in the future be used as a stepping stone to explore further out into the solar system.
But wouldn't it be cheaper to send robots in the meantime, Andy?
Yeah, it would be cheaper, but what happens when they go wrong? You're then just left with something that doesn't work with rovers that you can't mend or whatever, unless it's some kind of software thing that you can actually repair remotely from the Earth.
Yeah.
Oh, yeah,
It's all a
no,
bit
it's not working up there.
speculative. It's all a bit speculative to me. Isn't it?
Well, I suppose they'll look at the costs and the bottom line, and in the end, it might be cheaper to send robots. Elon Musk will be sending his robots up there to do it all.
Well, you just got to hope that they work, don't you? That's the thing. I mean, they've had great success of NASA with rovers on Mars, more or less, but a lot of other missions to Mars have been complete failures. So depends how. I mean,
I don't think Elon Musk would send anything up there because it wouldn't be visible from the Earth. He wouldn't be able to show off if it was on the far side.
no, he's a bit of a narcissist. He's like Trump, isn't he? Really, Musk.
Right.
Okay. Well, thanks again, John. That's quite food for thought, that.